Here we want to use integration by parts to find the integral sign of the square root of x. So first, let z be the square root of x, and this is the same as x to the 1/2. The derivative of z with respect to x is 1/2, and then subtract 1 from the exponent. 1/2 minus 1 is negative 1/2. X to the negative 1/2 is the same as 1 over x to the 1/2. X to the 1/2 is the same as the square root of x, but the square root of x is z. So we get 1 over 2z, and so we get dz is equal to 1 over 2z times dx. Multiply both sides by 2z, then we get 2z dz is equal to dx. So the integral of sine of the square root of x dx becomes sine of z, since the square root of x is z, and then dx is 2z dz, and then 2 is a constant, multiplication constant. We can move it and place it in front of the integral, so we get 2 times z, 2, and then we get the integral of z times sine of z dz. And for this part right here, we can use integration by parts. And so now let's find the integral of z times sine of z dz. Let u be z, and then the rest sine z dz be dv. And then the derivative of u with respect to z, derivative of z is just 1. So we get du is equal to dz. Here we have dv is equal to sine of z dz. Integrate both sides. dv is the same as 1 dv. The integral of sine of z is negative cosine of z. And therefore the integral of z sine z dz is equal to uv minus the integral of v du. U is z, v is negative cosine of z. So this is u, this is v, minus v, which is negative cosine of z, and then du is just dz. Minus negative becomes plus. The integral of cosine of z is just sine of z. Z originally is z was the square root of x, so in the place of z we have the square root of x. And this will be the cosine of the square root of x, and sine of the square root of x. And so the integral of z sine z dz is this. But recall that our integral originally, earlier, it was the 2 times the square root of z sine z dz. And therefore, the integral of sine of the square root of x will be 2 times this. And this is the answer.